If the work done by a body on application of a constant force is directly proportional to the distance traveled by the body, express this in the form of an equation in two variable and draw the graph of the same by taking the constant force as 5 units. Also, read from the graph the work done when the distance traveled by the body is 2 units or 0 units. So what they're talking about is this. Let's start with the diagram. So I have a body. Okay, let me draw it properly. Yes, this is a floor. This is a floor, and we are applying a force, a constant force of 5 units. Okay, so this object will move from say here till here for a distance of we don't know, some d, distance d. Okay, now the question is, express all of this relationship in terms of an equation, right? That's the question. If the work done blah 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 is directly proportional, that's very important, to the distance traveled by the body, express this form of equation to variable and draw the graph by taking the constant force. Also read the graph and work out when the distance traveled by the body is 2 units or 0 unit. Okay, so this is the question. So what else have they given is, the work is directly proportional to the distance, and if I remove this proportionality constant, that would be force, and that force is 5. So basically this is what they're talking about. Okay, with this rough understanding, let's start with writing given. So wherein we will start off with, let the distance traveled be, so the work is dependent on the distance, so we will take x. Here the work is dependent and the distance is independent. I mean, that's what they want us to express, I guess. Right, where is it? The work is directly proportional. Yes, this is what they want us to do. And we know the formula as well, actually. Work is equal to force into displacement. So this is independent while this is dependent. Depending on the distance, we will decide how much work is done. It's something like that. It's generally other way around. More the work we do, more the distance things are covered. But here we are looking at how much work is done depending on the distance. So this is independent, and this, all of this makes this dependent. Okay. So whenever you go with, naming x and y, try to take x to be the independent one. Right? And generally on the graph, y is dependent one. Let the work be y. So we have been given y is proportional to x, and this constant into x, and this happens to be 5 units. So basically this is everything. Okay, actually this is the working part also, but anyways, I finished it off. So express, oh yeah, we are done. This is your equation. Actually this is your working, so let me put it as working only. Right, now read the graph, work done, blah 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 blah. Draw the graph. Okay, we need the solutions. So how many? Very simple equation, 3 is enough. So whenever you look at anything simpler, just go with 3. So what should we substitute? Substitute x is equal to 0. Right? So y will be equal to 0. Next we will take substitute x is equal to 1, y is equal to 5. Very simple. And last, let's substitute x is equal to y is equal to 10. Okay. And next is a small table which we can draw it here itself, or we can draw it here also, it doesn't matter, the same. It'll be near to the graph also, right? This is x, this is y. When this is 0, this happens to be 0. When this is 1, this is 5. When this is 2, this is 10. And at last, we have the graph. Okay. So now 1, 2, 3, 4, 5. This is 10 actually. So we can go with 2, 4, 6, 8, 10. Actually, I could have gone with, anyways, I drew this. I just want to go with this itself. Okay, so I just want you guys to understand how to make use of the graph properly. Sorry, I should be looking at the values here itself. 0 and 0, 1 and 5. So this is 4 and this is 5. 2 and 10. Yes, we are done. All I have to do is join them. Okay. So let's finish off the naming. This is our distance. Generally in meters. This is our work. If you don't know the units, that's okay. Joules. And the equation happens to be y is equal to 5x, and this coordinate is 2, 10. This is 1, 5, and this is 0, 0. Okay. Well, also read from the graph work done when the distance traveled by the body is 2 units and 0 units. So from the graph, we have to look for the work is 0 unit. So the distance is also 0. When the work is 2 unit, we need to read this. It happens to be 0.5. Okay, right? They're asking that only now. Also read from the graph the work done. Okay, work done when the distance traveled is. If the distance traveled is 2, the work done is 10. So they are asking the other way around. So let me make that very clear. Read the question also again. Also read from the graph work done when the distance traveled by the body is. So when distance is 2 units, work we already know from the calculation is 10 unit. Okay, so they're not writing any joules and all. You guys need not. They're just writing unit. Okay, again, we'll just stick to what the question is. When distance is 0, obviously the work is 0. They're directly proportional, right? 0 unit. And that's your answer. Okay. So I think other than this thing looking not good, yes, now it is a bit soothing on the eye. This is your answer, and have a look at your graph. Okay, that's your answer. Oh yeah, let me pause and have a look, make you guys have a look. You can pause and have a look. Very simple values. Easy to draw, easy to verify.